There is a place on Earth so isolated that the closest humans to it are often not on this planet. They're in orbit, moving silently overhead at nearly 28,000 kilometers per hour, closer to that point than anyone standing on land. No cities surround it, no shipping routes cross it, no aircraft pass above it. If you were there would be no one within reach, no signal strong enough to matter, no system designed to help you. Because this is not just remote. It is the furthest possible distance from everything that defines human presence. A location so precisely empty that it had to be calculated, not discovered. And once you understand where it is and what surrounds it, you begin to realize something far more unsettling. This place is not rare. It is a consequence of how our planet is built, and it exists right now in the middle of the Pacific Ocean, unseen, unvisited, unaffected. This place is called Point Nemo. We tend to believe that the world has already been finished, not in the literal sense, but in the way it appears to us now, complete, outlined, measured, and stored somewhere in a system we can access at any moment. A planet that has been reduced to data. If you want to see a coastline, you can. If you want to trace a mountain range, you can zoom in until the ridges begin to show texture. Cities unfold into streets, streets into buildings, buildings into shadows cast at specific times of day. It gives the impression that nothing remains unresolved. From that perspective, Earth feels closed, not physically, but conceptually, as if the age of discovery has quietly ended without anyone needing to announce it. And it is easy to understand why. Satellites orbit constantly above us, capturing images of the surface in staggering detail. Every pass refines what we already know. Clouds move, forests shift, coastlines erode, and all of it is recorded, processed, updated. When we look at a modern map, it does not feel like a representation. It feels like reality itself, flattened and made accessible. But that sense of completion depends on a very specific condition. It depends on light. Everything we think we know about the surface of this planet comes from the ability to see it. Cameras, lenses, sensors, every system we rely on ultimately translates reflected light into information. As long as something is visible, it can be captured, analyzed, and understood. The process feels direct, almost effortless. The problem begins the moment that light stops working. At the edges of continents, where land gives way to water, something subtle shifts. The surface is still visible, still trackable, still mapped with precision. But what lies beneath it becomes something else entirely. The ocean does not reflect the same kind of information back to us. It absorbs, distorts, and conceals. From space, the oceans appear smooth, uniform, even calm. Vast fields of blue that suggest continuity and simplicity. But that image is deceptive. It shows only the surface, a thin boundary layer that hides nearly all of the structure below. What we call maps of the ocean floor are not images in the same way as maps of land. They are reconstructions, interpretations built from indirect measurements. Instead of light, we use sound. Ships move slowly across the water, sending pulses downward. These signals travel through the ocean until they strike something solid, then return as echoes. From the time it takes for that echo to come back, we estimate depth. From the strength and pattern of the return, we infer shape. But this process is limited. Each ship traces only a narrow path, leaving vast gaps between measured lines. Those gaps are filled in using models, assumptions, and extrapolations. The result is a surface that looks continuous, but is often based on sparse data points spread across enormous distances. In many parts of the ocean, the resolution of these maps is so low that entire features, mountains, valleys, ridges, could exist without ever being directly observed. This is not a failure of technology. It is a consequence of scale. The oceans cover more than 70% of the Earth's surface, and most of that area lies at depths that are difficult, slow, and expensive to study directly. Unlike land, where movement is relatively simple, the ocean imposes constraints that compound with depth. Pressure increases, light disappears, communication becomes unreliable. Every additional meter introduces new limitations, so we rely on what we can measure efficiently, even if it means accepting a degree of uncertainty. Over time, those approximations become familiar. They settle into our understanding of the world not as possibilities but as facts. We begin to treat them as complete. This is where the illusion forms, because the difference between a high-resolution image and a low-resolution model is not always obvious when both are presented in the same format. On a screen, everything looks equally real, equally finished. The gaps are hidden by design, and so, without noticing it, we shift from knowing the world to believing we know it. That belief holds as long as we stay within the boundaries of what has been directly observed. But beyond those boundaries, beneath the surface of the ocean, the certainty begins to thin. The deeper the water becomes, the less precise our understanding is. Not because we lack curiosity, but because the environment itself resists clarity. Light fades quickly, disappearing entirely within a few hundred meters. Cameras become useless without artificial illumination, and even then, they reveal only a narrow field surrounded by darkness. At greater depths, even sound begins to behave differently. Temperature, pressure, and salinity create layers that bend and scatter signals in ways that complicate interpretation. What returns to the surface is no longer a simple reflection, but a distorted version of it. And yet, despite all of this, we still present the ocean as something mapped, something known. It is a subtle but important distinction. We know where the oceans are, we know their approximate depths, their boundaries, their general structure. But knowing that something exists is not the same as understanding it in detail. It is not the same as seeing it. On land, maps confirm what we already experience. In the ocean, maps often replace experience entirely. This is what makes places like Point Nemo possible, not because they are hidden, but because they exist within a part of the planet where our knowledge is inherently indirect. A place defined not by what we see, but by what we calculate. And when you begin to look at the Earth through that lens, not as a finished surface, but as a layered system with vast regions still interpreted rather than observed, the idea of a fully known planet starts to dissolve. What remains is something more complex, a world where certainty depends on conditions, where visibility defines understanding, and where, beyond a certain point, even the most familiar maps begin to lose their meaning, and somewhere within that loss of clarity, a location exists that is not defined by features or history or visibility at all, but purely by distance. A place that only becomes real once everything else has been measured. Once you begin to accept that much of the planet exists beyond direct observation, the idea of a place defined entirely by distance starts to feel less abstract and more inevitable. Not because it was waiting to be found in the traditional sense, but because it emerges naturally from the way Earth is arranged. Continents are not evenly distributed. Islands are not placed with symmetry. The surface of the planet is irregular, shaped by geological processes that have nothing to do with human perception. and when those irregularities are measured with precision, certain patterns appear, one of them being the existence of a single point that is farther from land than any other. That point was not identified by an explorer or encountered by accident. It was calculated. In 1992, a Croatian engineer named Hrvoje Lukatela used a computational approach to determine the oceanic pole of inaccessibility, the location in the ocean that maximizes distance from the nearest land in all directions. The method itself was not complicated in principle, but it required something that had only recently become available at the time: sufficiently accurate global geographic data and the computational tools to process it. The Earth was divided into a grid of possible locations, and for each of those points, the distance to the nearest piece of land was calculated. Not estimated, but computed with precision using spherical geometry, taking into account the curvature of the planet. The process was exhaustive. Every possible candidate was tested, compared and eliminated until only one remained. The point that was, by definition, the most isolated location on the surface of the ocean. The result was a set of coordinates in the South Pacific, roughly at 48 degrees south latitude and 123 degrees west longitude. A place with no visible markers, no distinguishing features, no indication of its significance unless you already knew what you were looking for. What makes this different from traditional discovery is not just the method, but the nature of the result. Most places we recognize gain meaning from what they contain. Mountains, rivers, cities, ecosystems, they are defined by presence. Point Nemo is defined by absence. It is not important because of what is there, but because of what is not. Its significance lies entirely in its relationship to everything else. The nearest land to this point is not a single continent, but 3 different locations, each roughly equidistant. Ducie Island, part of the Pitcairn Islands to the north; Motu Nui, a small island off Easter Island to the northeast; and Maha Island near Antarctica to the south. Each of these is more than 2,600 kilometers away. That distance is not approximate. It is the maximum possible separation between a point in the ocean and any landmass on Earth. This is what makes the concept precise. There is no other location where you could stand or float and be farther from land in every direction. The geometry of the planet does not allow it. It is tempting to think of this as a kind of extreme remoteness, an extension of the same idea that defines deserts, polar regions, or isolated islands. But it is fundamentally different. Those places, no matter how distant, still exist as part of a landscape. They have boundaries, features, identities. Point Nemo does not. It exists only as a solution to a problem, a point that satisfies a condition. If you were to remove all maps, all coordinates, all systems of measurement, there would be no way to distinguish it from the surrounding ocean. You could pass directly through it without noticing anything at all. This is why it had to be derived rather than discovered. There was no visual cue to guide anyone there. No natural landmark to indicate that this place was different from any other patch of water in the Pacific. Only once the entire surface of the Earth had been measured and processed could such a point emerge. In that sense, Point Nemo represents a different kind of knowledge. Not experiential, but computational. It belongs to a category of places that exist because we have developed the tools to define them, not because they present themselves to us. This raises an interesting question about how we think about geography. For most of human history, places were known through direct interaction. You travelled to them, saw them, described them. Their reality was tied to experience. With the development of global mapping and computational analysis, that relationship has shifted. We now recognize locations that have never been directly observed in any meaningful way, simply because they satisfy certain criteria within a system. Point Nemo is one of the clearest examples of this shift. It is a place that exists fully within our understanding of the planet, yet remains almost entirely outside of our experience of it, and because of that, it challenges the way we think about what it means to know a place. Knowing its coordinates does not tell you what it feels like. Knowing its distance does not convey its scale in human terms. It is precise in definition, but abstract in reality. This is part of what makes it so compelling. It sits at the intersection of mathematics and geography, of certainty and absence. A location that is exact down to the meter, yet indistinguishable from its surroundings. A point that only becomes meaningful when viewed from a global perspective and loses that meaning entirely when approached locally. And as the calculation reveals its position, something else becomes clear as well. This level of isolation is not the result of something unusual happening at that specific spot. It is the natural outcome of how land and water are distributed across the planet. If the continents were arranged differently, if the oceans were shaped differently, the point would shift. It is not fixed by anything inherent to that location, but by the configuration of everything around it, which means that Point Nemo is not a special place in the way we usually define special. It is a consequence, a point that exists because the rest of the world is arranged the way it is. And understanding that changes how we think about it. Because it is not just a curiosity or a geographic extreme. It is a reminder that even something as vast and seemingly continuous as the ocean can produce edges, not physical ones, but conceptual ones, where distance itself becomes the defining feature. And once that idea takes hold, the next step is not to locate it on a map, but to understand what that distance actually means when you place yourself within it. If you were placed at those coordinates without being told where you were, nothing in your surroundings would help you understand what makes that location different from any other point in the open ocean. There is no horizon that behaves differently, no shift in the colour of the water, no change in the rhythm of the waves that signals you have arrived somewhere significant. The surface stretches in every direction with the same quiet consistency, broken only by wind and weather, never by structure. And that is the first real confrontation with what Point Nemo actually is, not a place that reveals itself, but one that refuses to. Because unlike almost every environment we are familiar with, this is a location defined by the complete absence of reference. On land, orientation is instinctive. Even in unfamiliar terrain, there are always clues. The slope of the ground, the position of the sun relative to visible landmarks, the shape of distant features. Even at sea, closer to coasts or islands, there is usually some variation. Birds indicating land nearby, changes in water colour hinting at depth differences, currents that carry subtle patterns. But here, those cues disappear. The water is deep, often more than 4,000 meters below, far beyond the reach of light or any visible interaction with the seafloor. There are no nearby land masses to influence the ecosystem in obvious ways. No sediment plumes, no drifting vegetation, no coastal life extending outward. What remains is a kind of visual and spatial uniformity that is difficult to fully process until you imagine being inside it. Because without variation, the brain struggles to measure distance, to anchor itself, to interpret scale. The horizon becomes less of a boundary and more of an illusion, a perfect circle that moves with you, offering no sense of progress or direction. If you were to travel through this region, there would be no moment where you could say you had entered it. No threshold to cross. The Transition is gradual, almost imperceptible, as the last signs of proximity to land fade away behind you. Fewer birds, less debris, longer stretches of uninterrupted water, until eventually, without any clear signal, you find yourself in a space where nothing external confirms your position. This is what makes it feel structureless, not because it lacks physical reality, but because it lacks the features we rely on to interpret that reality. And this has a subtle, psychological effect. Humans are not accustomed to environments without markers. Even in vast deserts or polar regions, there are still textures, dunes, ice formations, shadows that create a sense of dimension. Here, the surface is constantly shifting, but never in a way that creates stable reference points. Every wave is temporary, every pattern dissolves as quickly as it forms. There is nothing to hold on to visually, nothing to build a mental map around. Navigation, in this context, becomes entirely dependent on instruments, coordinates, compasses, satellite positioning. Without them, direction loses meaning. You could be moving in a straight line or in circles, and there would be no way to tell from observation alone. This is not just a theoretical limitation. Before modern navigation systems, this kind of environment represented a real boundary to human movement, not because it was physically impossible to cross, but because it was impossible to interpret reliably. And even today, with all the technology available, the experience itself does not change. The instruments tell you where you are, but they do not change what you see. They do not add structure to the environment. They only translate it into data. What you perceive remains the same, an unbroken field of water, extending beyond your ability to contextualize it. This is where the idea of a destination begins to lose its usual meaning. A destination implies arrival, a point where something changes, where there is a sense of completion or recognition. But here, arrival is indistinguishable from any other moment in the journey. You reach the coordinates and nothing happens. The ocean does not acknowledge it. There is no visual confirmation, no environmental shift. You are simply at a point that has significance only because it was defined that way from a distance. And this creates a kind of disconnect between the concept of the place and the experience of it. From a global perspective, Point Nemo is precise, measurable, unique. From a local perspective, it is indistinguishable, almost abstract. The significance collapses as you approach it, not because it disappears, but because it was never embedded in the physical environment to begin with. It exists in the relationship between locations, not in the location itself. And this is what makes it fundamentally different from any other extreme on Earth. The highest mountain, the deepest trench, the driest desert, all of these can be experienced directly. Their defining characteristics are present, visible, tangible. Point Nemo cannot be experienced in that way. Its defining characteristic is distance, and distance is not something you can see, you can only measure it. Which means that being there feels exactly like being anywhere else in the open ocean, unless you carry with you the knowledge of what that distance represents. And even then, that knowledge remains abstract, a number, a concept, rather than something that translates into the environment around you. This is why the region feels empty in a way that goes beyond physical emptiness. It is not just that there is nothing there, it is that there is nothing to interpret, no cues to build meaning from, no features to organize perception, just a continuous surface that offers no distinction between one point and the next. And yet, within that uniformity, there is a kind of clarity. Because when all reference points are removed, what remains is the raw scale of the planet itself, not broken into regions or landmarks, but experienced as a continuous expanse, a reminder that most of Earth is not structured in the way we're used to thinking about it, that beyond the edges of continents and the boundaries we define, there are spaces that exist without narrative, without identity, without any inherent reason to stand out, until we impose one from afar. And once you begin to see it that way, the question shifts again from what this place looks like to what it actually feels like to exist within that level of isolation, not just visually but physically, environmentally and biologically, in a part of the ocean where even life itself begins to thin out in ways that challenge expectations. What gives this place its meaning is not what surrounds you, but how far away everything else is, and that distance is so extreme that it begins to slip outside the way humans normally understand space. From the exact point of Point Nemo, the nearest land in any direction lies more than 2,600 kilometers away. That number sounds large, but numbers alone rarely translate into something you can feel. To understand it, you have to begin breaking it into experiences. If you were on a modern cargo ship moving at a steady speed of around 30 kilometers per hour, it would take you more than 3 full days of continuous travel to reach the nearest landmass, assuming perfect conditions, no storms, no delays, no course corrections. And even that is an optimistic scenario. In reality, ocean travel is rarely so consistent. Weather shifts, currents interfere, and routes are adjusted for efficiency rather than directness. That means the actual journey would likely stretch longer, not shorter. Now, imagine making that same journey in reverse, leaving the last trace of land behind you, watching it shrink until it disappears completely below the curve of the Earth, and then continuing forward, hour after hour, day after day, with nothing replacing it. No new shape on the horizon, no signal that you are approaching anything, just distance accumulating in a way that offers no visual feedback. Even by air, the scale remains difficult to process. A commercial jet travelling at roughly 900 kilometers per hour would still need close to 3 hours of uninterrupted flight to cross that distance. But commercial jets do not fly over this region. There are no routes that pass directly above Point Nemo because there is no reason to. No airports to connect, no emergency landing options, no infrastructure below that justify the risk. This is one of the few places on Earth where even the sky reflects the isolation of the surface beneath it. So when you imagine distance here, you have to remove the usual reference points of travel. There are no checkpoints, no halfway markers, no gradual sense of approaching something. The distance exists all at once, surrounding you equally in every direction. And that symmetry is what makes it so unusual. Most remote places are remote in a directional way. A mountain might be far from civilization, but there is always a direction that leads back. A desert might stretch for hundreds of kilometers, but there is still an edge, a boundary where it transitions into something else. At Point Nemo, that directional logic breaks down. It does not matter which way you choose to go, north, south, east or west, the outcome is the same. The distance to land changes only slightly, but never meaningfully. You are always, in every direction, as far away as you can possibly be. This creates a kind of geometric isolation that is almost mathematical in its perfection. The point exists not because it is far from something specific, but because it is maximally far from everything at once. It is the center of an enormous, invisible circle drawn across the surface of the Pacific Ocean, where the radius extends outward to the nearest edges of land, each one equally distant, each one equally unreachable without a long, uninterrupted journey. And yet, even when you understand this intellectually, the human mind resists fully absorbing it. because on land, distance is rarely experienced as pure space. It is broken up by changes in terrain, by interactions, by moments that mark progress. A journey across 2,600 kilometers of land would pass through cities, landscapes, cultures, variations that give the distance texture. Over the open ocean, that texture disappears. The distance becomes continuous, unbroken, almost abstract. Hours pass, then days, without anything fundamentally changing in your surroundings. And without change, the sense of scale begins to flatten. It becomes harder to distinguish between 1 hour and the next, one day and the next, because there are no events to anchor them. This is why people often underestimate how large the oceans truly are. When you look at a map, especially a digital one that can be zoomed in and out instantly, the Pacific Ocean becomes just another blue space, something that can be crossed with a simple gesture of your fingers. But in reality, that space represents distances so vast that they challenge not just logistics, but perception itself. And Point Nemo sits at the most extreme version of that reality, where the ocean is not just large, but maximally large in relation to land. The idea that every direction is equally empty also changes how you think about escape or rescue. In most situations, if something goes wrong, there is at least a preferred direction to move toward help. Even in remote areas, there is usually a closest point of civilization, a known route, a path that reduces distance rather than maintaining it. Here that concept becomes irrelevant. There is no nearest direction that feels meaningfully closer. Every option requires the same commitment, the same endurance, the same exposure to the environment over an extended period of time, and that is where the abstraction of distance turns into something more tangible. Because while the ocean may look the same in every direction, the time required to cross it is very real. The fuel needed, the supplies, the physical limits of both machines and humans, all of these become critical factors when distance is no longer something that can be reduced quickly or adjusted around. It is simply there, fixed, indifferent to your presence within it. And perhaps the most striking part of all of this is that this extreme distance is not rare in the sense of being hidden or inaccessible. It is not locked away behind barriers or confined to a single isolated feature. It is part of the continuous surface of the planet, existing quietly in a region that most people will never see, not because it is impossible to reach, but because there is no practical reason to go there. The isolation is not enforced, it is simply a consequence of geometry and geography aligning in a way that leaves this point as far removed from everything else as the Earth allows. And once you begin to think about it in those terms, the distance stops being just a measurement and starts becoming the defining characteristic of the place itself, shaping not only how it is understood, but how it is experienced by anything that happens to pass through it, including the forms of life that exist beneath the surface, where that same isolation continues to influence conditions in ways that are far less visible but no less significant. And when you begin to overlay human movement onto that geometry, something else becomes clear. This place is not just isolated because of distance, it is isolated because we have collectively decided, over time, to stay away from it. Not in a conscious, coordinated way, but through thousands of small decisions made by shipping companies, airlines, and navigation planners who all optimize for efficiency, safety, and purpose. And Point Nemo offers none of those things. Modern shipping routes are not random lines drawn across the ocean. They are carefully calculated paths that balance fuel consumption, weather patterns, currents, and the need to connect major ports. Ships move where trade exists, where goods need to be transported, where time can be saved by following predictable routes. The Pacific Ocean, despite its size, is filled with these invisible highways, connecting Asia to the Americas, linking island chains, tracing arcs that minimize distance while maximizing safety. But if you look at those routes closely, they curve around vast empty spaces, not because they cannot cross them, but because there is no reason to. Point Nemo sits far from any major port, far from any strategic waypoint, far from anything that would justify the cost of passing through it. A cargo vessel does not gain anything by cutting directly across that region. There are no stops to make, no alternate routes to connect to, no support infrastructure if something goes wrong. And in maritime navigation, that last point matters more than anything else. The ocean is unpredictable. Storms can form quickly, mechanical failures can happen without warning, and when they do, proximity to help becomes critical. Routes are often designed not just for speed, but for access, to ensure that if assistance is needed, it can be reached within a reasonable time frame. At Point Nemo, that safety net disappears entirely. There is no nearby port, no nearby shipping lane dense enough to guarantee passing. Vessels, no quick diversion that leads to shelter. Choosing to pass through that region is choosing to operate without backup, and so, over time, shipping lanes have naturally formed around it, bending away from the center of that emptiness, reinforcing the isolation that geography created in the first place. The same logic applies in the air, but with even stricter constraints. Commercial aviation operates under rules that prioritize safety above all else, and one of those rules is the requirement to remain within a certain distance of emergency landing options. Even long-haul flights that cross oceans are carefully planned to ensure that, at any given point, there are reachable airports within a defined time window. This is why flight paths often appear curved on maps, not because they are inefficient, but because they follow great circle routes while still maintaining access to alternate landing sites. Over the Pacific, those options are limited to a handful of islands and coastal regions. Point Nemo lies beyond the practical reach of most of them. Flying directly over it would mean extending that distance to a point where emergency planning becomes far more complicated. And in aviation, unnecessary risk is avoided whenever possible. So flight paths shift, sometimes only slightly, sometimes significantly, but always enough to keep aircraft within a safer operational envelope. The result is that even the sky above this region remains largely empty, not because planes cannot physically fly there, but because there is no operational justification to do so. And when you combine these patterns, something interesting emerges. The isolation of Point Nemo is not static. It is actively maintained by human systems that prioritize connection elsewhere. Trade routes concentrate around areas of demand. Air traffic clusters around corridors of movement. Infrastructure grows where it can be supported and sustained. And everything outside of those networks becomes, by default, less traveled, less observed, less integrated into the global system. Point Nemo is the extreme end of that process, a place that sits so far outside of economic and logistical relevance that it never becomes part of the network to begin with. There are no cables running across its exact center, no pipelines, no research stations, no platforms. Even scientific expeditions, which often seek out remote and understudied areas, rarely prioritize this exact location, because while it is unique in terms of distance, it does not offer specific features that would justify the cost of reaching it. Scientists study ocean currents, ecosystems, geological formations, but those studies are usually tied to regions where something distinct can be measured or observed. Point Nemo, by contrast, represents a kind of baseline, an absence of variation that, while conceptually interesting, is logistically expensive to access. And so it remains largely unvisited, not out of mystery but out of practicality. What makes this particularly compelling is that the isolation becomes self-reinforcing. The fewer reasons there are to go there, the fewer routes pass through it. The fewer routes pass through it, the less infrastructure develops around it. And the less infrastructure exists, the fewer opportunities there are for new reasons to emerge. It is a feedback loop that keeps the region empty, not through restriction, but through disinterest. And yet, that disinterest is precisely what preserves its uniqueness. Because in a world where most places are defined by their connections, their accessibility, their integration into global systems, Point Nemo stands apart as a place that exists almost entirely outside of that framework. It is not that humans cannot reach it. It is that, in almost every practical sense, they choose not to. And that choice, repeated over decades, across industries and technologies, has turned a mathematically defined point into something that feels far more absolute, a location where isolation is not just measured in kilometers, but in the absence of human presence, movement, and purpose, extending not only across the surface, but downward into the waters below, where the effects of that isolation begin to shape the very nature of life itself in ways that are far less visible, but far more profound. And when that absence extends not just across distance, but into perception itself, the experience begins to shift from something physical into something deeply psychological, because the human mind depends on feedback in ways that are easy to overlook until it disappears. In most environments, even quiet ones, there is a constant stream of subtle information being processed in the background. Changes in light, variations in sound, movement at the edge of vision, textures underfoot. All of these elements continuously confirm that you are moving through a space that is structured, responsive, and real. They allow you to measure time, to understand distance, to orient yourself without consciously thinking about it. But in a place like this, many of those signals are reduced to a minimum, and what remains is not silence, but repetition. The sound of water, the motion of waves, the unbroken horizon, all continuing without interruption, without escalation, without any clear beginning or end. And over time, that repetition starts to have an effect. Not immediately, not in a dramatic way, but gradually, as the brain begins to search for variation that simply is not there. This is where disorientation begins, not because you are lost in a traditional sense, but because the usual anchors that define position and movement have been stripped away. On land, even without a map, you can often tell if you're making progress. The landscape changes, the angle of the sun shifts relative to familiar objects. Distances can be estimated based on visible reference points. At sea, especially in a region like this, those cues disappear. The horizon remains constant, always the same distance away, always the same shape, offering no indication of how far you have travelled or in which direction. The water beneath you is in motion, but that motion is relative. It does not tell you anything about your own movement unless you have something fixed to compare it to. And without that comparison, movement becomes abstract. You may be travelling for hours, covering significant distance, but the environment gives you no confirmation of that progress. This disconnect between action and feedback is something the human brain is not well adapted to handle. It creates a subtle tension, a sense that something is missing, even if you cannot immediately identify what it is. Over longer periods, this can develop into a more pronounced psychological effect. The monotony of the environment begins to compress time, making hours feel longer or shorter in unpredictable ways. Without distinct events to mark transitions, the passage of time becomes harder to track. Days can blur together, not because they are identical, but because there are no strong signals to separate them. This is a phenomenon observed in various isolated environments, from polar expeditions to long-duration space missions. But the open ocean adds an additional layer, because the environment is not just isolated, it is also visually uniform in a way that removes depth and variation from perception. Even the color palette remains consistent, shades of blue and grey that shift with weather and light, but never in a way that introduces new structure. And within that uniformity, the mind begins to compensate. It starts to search for patterns, to interpret small variations as meaningful, to create a sense of change where none exists. This can lead to moments where the environment feels almost deceptive, where distances seem to fluctuate, where the horizon appears closer or farther than it actually is, where the absence of reference points allows perception to drift slightly out of alignment with reality. These are not dramatic hallucinations, but subtle distortions, small adjustments the brain makes in an attempt to maintain orientation in a space that does not provide the usual tools to do so. There is also the factor of isolation in a more literal sense, the awareness that you are far removed from any form of immediate assistance or interaction. Even if you are not alone, even if you are part of a crew or a team, the knowledge of distance changes the way the environment is experienced. It adds a layer of finality to the surroundings, a recognition that what is around you is not easily escaped or altered. This is different from being in a remote location on land, where there is often at least the possibility of moving towards something, of reaching a boundary, of encountering variation. Here, the environment does not offer that possibility in any immediate sense. It remains consistent, continuous, and indifferent to your presence within it. And yet, this does not necessarily translate into fear. In many cases, it produces a different kind of response, a heightened awareness of scale and of one's own position within it. Without distractions, without competing signals, the mind has more space to focus on the environment itself, to process the vastness in a way that is difficult to replicate elsewhere. Some describe it as calming, others as unsettling, but in both cases it is a direct result of the same underlying condition, the removal of complexity from the surroundings. What remains is a simplified version of the world, reduced to its most basic elements: water, sky, motion, light. And in that simplicity, the usual boundaries between foreground and background begin to blur. The horizon is no longer just a line in the distance, it becomes the defining feature of the entire visual field. The movement of the ocean is no longer just a detail, it becomes the primary source of variation, the only thing that changes in a way that can be observed continuously. This kind of environment reveals something fundamental about how humans interact with space. We're not just observers, we are interpreters, constantly building meaning from the information around us. And when that information is reduced, the process itself becomes more visible. You begin to notice how much you rely on contrast, on difference, on the presence of objects and features that allow you to define one thing in relation to another. Without those elements, the world does not disappear, but it becomes harder to pass, harder to organize into something that feels familiar. And that is perhaps the most important aspect of true isolation. Not just that you are far from everything else, but that the environment itself offers very little in return, very little feedback, very little structure to engage with. It is not hostile in an obvious way, but it is not accommodating either. It simply exists, unchanged by your presence, providing only the minimum information required to understand that you are there, and nothing more. And as that experience continues, as hours extend into days, the question begins to shift once again, from how the environment affects perception to how it shapes the conditions for life itself, in a region where the same absence of structure and input extends beneath the surface, influencing not just how the ocean looks, but what it is capable of supporting at a biological level. And when you take that sense of distance and shift it away from the surface, something even more unexpected begins to emerge, because the closest humans to this place are not always on Earth at all. They are above it. At any given moment, the International Space Station moves across the sky at an altitude of roughly 400 kilometers, circling the planet every 90 minutes. It does not stay in one place. It traces a constantly shifting path, passing over oceans, continents, and everything in between. But there are moments, brief and precise, when its orbit carries it over the central Pacific, directly above the region where Point Nemo lies. And when that happens, the distance between the station and the surface below is significantly smaller than the distance between that same point and the nearest human on land. The difference is not subtle. If you're standing at Point Nemo, the closest coastline is more than 2,600 kilometers away. The astronauts overhead are, in comparison, less than 1/6 of that distance from you. It is a reversal of how we usually think about proximity. Space is supposed to be distant, unreachable, far beyond the scale of everyday experience, and yet here, in this specific alignment, it becomes the nearest place where other humans exist. Not beside you, not across the ocean, but above you, moving at a speed of over 28,000 kilometers per hour, visible only as a small, fast-moving point of light if conditions allow. This comparison does something more than just provide a surprising fact. It changes the orientation of isolation itself. Until now, everything has been measured horizontally, distances across the surface, across water, across the curvature of the Earth. But the moment you introduce a vertical dimension, the entire perspective shifts. Isolation is no longer just about how far away you are from land, it becomes about how far away you are from humanity in any direction. And in that three-dimensional sense, Point Nemo occupies a position that is almost paradoxical. It is one of the most remote places on the surface, yet it is not the most remote place relative to human presence. Because above it, at a fraction of the distance, there are people orbiting the planet, connected to global communication networks, monitored continuously, part of a system that is anything but isolated. The contrast between those two realities is difficult to fully process. On the surface, there is nothing. No infrastructure, no traffic, no signal of human activity. Above it, there is one of the most advanced pieces of technology ever constructed, inhabited, operational, and constantly in motion. And for a brief moment during each pass, those two extremes align, one directly beneath the other, separated by a distance that is, in global terms, relatively small. But that proximity is deceptive, because while the astronauts are physically closer, they are not accessible in any meaningful way. There is no interaction between those two points, no exchange, no awareness, no connection beyond the abstract knowledge that both exist in the same vertical column of space. The station continues its orbit, the ocean continues its motion, and the alignment passes without consequence. What makes this even more compelling is how it highlights the difference between physical distance and practical distance. The astronauts are closer in terms of kilometers, but they are infinitely further in terms of accessibility. Reaching the nearest land, while difficult, is theoretically possible with the right vessel, the right conditions, and enough time. Reaching the space station from that same point is not just impractical, It is impossible without an entirely different level of technology, infrastructure and support, and yet in purely spatial terms, it is the closer destination. This is where the concept of isolation becomes layered. It is not a single measurement, but a combination of distances, directions and limitations that interact in ways that are not always intuitive. Horizontally, you are as far from land as you can be. Vertically, you are relatively close to a place where humans exist. But those two realities do not cancel each other out. They exist simultaneously, creating a kind of spatial contradiction that reinforces just how unusual this location is. It is not just isolated in one dimension, it is positioned at a point where different kinds of isolation intersect. And when you consider how often the station passes overhead, roughly 16 times a day as it completes its orbit, the idea becomes even more striking. At various points, it crosses over the Pacific, sometimes near this region, sometimes directly above it, depending on the specifics of its orbital path at that time. Each pass is brief, lasting only a few minutes, but during those moments, the closest humans to one of the most remote places on Earth are not on the planet's surface at all. They are moving above it, part of a system that is continuously connected to the rest of the world, even as they pass over a place that remains disconnected from it. This contrast also reveals something about how we define presence. The astronauts are physically there, in the sense that they occupy space above that point, but their presence does not translate into influence on the environment below. They do not change it, they do not interact with it, they do not even perceive it directly in most cases. From their perspective, the ocean is just one part of a much larger view, a continuous surface that stretches across the planet, broken only by the outlines of continents and cloud formations. The specific point beneath them does not stand out. It is not marked, not highlighted, not visually distinct. It is just another section of blue in an already vast expanse. And that, in a way, brings the idea full circle. Because even when you introduce the closest possible human presence, even when you redefine distance in a way that makes space feel nearer than land, the experience of the place itself does not change. It remains what it is, an area of the ocean that offers no visual or physical indication of its uniqueness, existing quietly beneath the sky that occasionally carries the nearest humans above it, without ever bridging the gap between those two realities. And that vertical connection does not end with astronauts passing overhead, because there is another, far more direct relationship between this place and space, one that turns Point Nemo into something entirely different from what it appears to be on the surface. It is not just a remote point in the ocean, it is a destination. Not for ships, not for aircraft, but for spacecraft returning from orbit, objects that have spent months or years circling the Earth before being deliberately guided back down into the atmosphere. When a spacecraft reaches the end of its operational life, it cannot simply be left in orbit indefinitely. Over time, orbital decay, collisions, and the accumulation of debris create increasing risks, so space agencies plan controlled re-entries, carefully calculated descents where the spacecraft is directed toward a specific region of the planet, one where the likelihood of causing harm is as close to zero as possible. And when those calculations are made, when engineers map out where something should fall after travelling at orbital speeds and breaking apart in the atmosphere, the same place appears again and again, not because it is visible, not because it is accessible, but because of what it lacks. Point Nemo offers the largest possible buffer between falling debris and human populations. The same geometry that defines its isolation on the surface makes it the safest target from above. When a spacecraft begins its descent, it does not fall as a single intact object. As it encounters the atmosphere, friction builds rapidly, temperatures rise to thousands of degrees, and most of the structure burns away. But not all of it. Larger components, denser materials, sections designed to withstand extreme conditions. These can survive the re-entry process and continue falling toward the ocean below. Predicting exactly where each fragment will land is complex. Variables such as angle of entry, atmospheric conditions, and the breakup pattern of the spacecraft all influence the final distribution of debris. What engineers can control, however, is the general region where that debris will be concentrated, and by targeting Point Nemo, they ensure that even with those uncertainties, the fragments will fall into one of the most uninhabited areas on the planet. This is why the region is sometimes referred to as a spacecraft cemetery, not in a literal sense of visible remains, because most of what falls is scattered across a vast area and sinks quickly into the depths, but in the sense that it is where missions come to an end. Over the years, dozens of spacecraft have been guided toward this point, each one marking the conclusion of a journey that began far above the Earth. One of the most well-known examples is the Russian space station Mir. After operating for 15 years, it was decommissioned in 2001. Engineers planned its re-entry with precision, calculating the timing and trajectory so that its remains would fall into this remote section of the Pacific. As it descended, it broke apart, streaking across the sky before fragments scattered across the ocean, disappearing beneath the surface. It was not an accident, not an uncontrolled fall, but a deliberate return, ending in the one place where the risk to human life was minimized to the greatest extent possible. The same approach has been used for numerous cargo spacecraft, vehicles designed to deliver supplies to orbiting stations and then disposed of once their mission is complete. After detaching, they are guided back down, their paths adjusted so that their final moments intersect with this same region. Over time, this has created a pattern, not visible from above or below, but present in the history of spaceflight itself. A recurring destination that exists not because of what it offers, but because of what it avoids. And looking forward, this connection is expected to continue. Plans for the eventual decommissioning of the International Space Station include a controlled re-entry that will likely target this same area. The station is far larger than any of the spacecraft that have come before, a complex structure that has been continuously inhabited for decades. Bringing it down safely will require careful coordination, precise calculations, and a region of the planet that can absorb the remains without consequence. Once again, the logic points to the same place, the same coordinates, the same absence of human presence that makes it uniquely suited for this purpose. What makes this relationship so striking is how it links two extremes that are usually considered separate. The most advanced technology humanity has created, operating in the vacuum of space, and one of the most untouched, unvisited areas on Earth, existing quietly on the surface of the ocean. They intersect not through exploration or discovery, but through conclusion. One represents the edge of human capability, the other the edge of human absence, and between them is a process that transforms one into the other, turning spacecraft into fragments, turning orbit into impact, turning presence into disappearance. From a distance, this might seem like a contradiction, that a place defined by its emptiness becomes a focal point for something as significant as the end of a space mission. But in reality, it is a continuation of the same principle that has defined Point Nemo from the beginning. Its value lies not in what is there, but in what is not. No population to endanger, no infrastructure to damage, no ecosystems that are uniquely vulnerable compared to others. Just open ocean, deep water, and a level of isolation that makes it the safest endpoint for objects that cannot remain where they are. And yet, even with this role, the experience of the place itself does not change. If you were there at the moment a spacecraft re-entered overhead, you might see nothing at all. The event could occur beyond the horizon, or high enough in the atmosphere that it remains invisible from the surface. Even if fragments reach the water nearby, they would disappear quickly, sinking into depths where they become part of an environment that is already difficult to observe. The connection exists, but it is not one that reveals itself easily. It is another layer of meaning that exists alongside the others, adding complexity to a place that, on the surface, appears to have none. And as that pattern continues, as more missions end in this same region, the idea of Point Nemo expands beyond geography into something that connects the surface of the Earth with the space above it, not through presence, but through absence, not through activity, but through the deliberate choice to direct things toward the one place where their impact will be least felt. What makes that idea even more compelling is what happens after the moment of impact, because from a distance it is easy to imagine these spacecraft simply vanishing, reduced to ash in the atmosphere, erased from existence as they fall into one of the most remote parts of the ocean. But that is not entirely what happens. The reality is more gradual, more physical, and in some ways more enduring. As a spacecraft begins its descent, the process is violent and precise at the same time. Travelling at orbital speeds, it encounters the upper layers of the atmosphere where friction builds almost instantly. Temperatures rise to extremes that no conventional material can withstand indefinitely. Outer panels begin to burn away, components weaken, structures fracture. What was once a unified object becomes a cascade of fragments, each one following its own slightly different path as the forces acting on it change moment by moment. Smaller pieces are consumed completely, reduced to gases and microscopic particles that disperse into the atmosphere. But larger components behave differently. Fuel tanks, reinforced modules, dense structural elements, these can survive long enough to continue their descent. By the time they reach lower altitudes, they are no longer part of a single spacecraft, but individual objects, falling at high speed toward the surface below. And this is where the idea of a graveyard begins to take shape, not as a single point, but as a wide, invisible impact zone spread across hundreds of kilometers of open ocean. When engineers target this region, they are not aiming for a precise landing site. They are defining an area where debris will be distributed, a zone large enough to account for the uncertainties of re-entry, yet remote enough that even the outer edges of that distribution remain far from human activity. The fragments that survive the descent strike the water with significant force, but the ocean absorbs that energy quickly. There is no visible accumulation, no debris field that floats on the surface. Most of these objects sink almost immediately, descending through thousands of meters of water until they reach the seafloor, where they come to rest in darkness. And over time, this process repeats. One spacecraft after another, each one following a similar path, each one contributing its remains to the same general region. Not in a way that creates a recognizable structure, but in a way that gradually adds to what is already there. Scattered components, separated by distance, resting on a seabed that is already one of the least explored environments on the planet. It is not a graveyard in the traditional sense. There are no markers, no visible boundaries, no clear indication of where one object lies in relation to another. But conceptually, it is a place where human-made objects accumulate, not on the surface where they can be seen, but below it, out of reach, out of sight, yet still present. This challenges the way we think about disappearance. When something falls into the ocean, especially in a region this remote, it feels as though it is gone, removed entirely from the world we interact with. But in reality, it has only changed location. The materials remain, the structures persist in altered forms. The history of those objects continues, just in an environment that is largely inaccessible. Over time, corrosion begins to take effect. Salt water interacts with exposed surfaces, slowly breaking down metals, altering shapes, integrating what was once manufactured into the natural processes of the ocean floor. But this is not an immediate transformation. It happens over years, decades, sometimes longer, depending on the materials and conditions, which means that at any given moment, beneath the surface of this remote region, there are remnants of missions that once existed far above it, now resting in a completely different context. And because the seafloor in this part of the Pacific is so deep and so rarely visited, much of this remains unobserved. Unlike shipwrecks in shallower waters, which can be explored, documented, even turned into sites of study or interest, the objects that fall near Point Nemo are effectively removed from direct human observation. They become part of an environment that is already difficult to access, where pressure, darkness, and distance combine to limit exploration. This creates a kind of final separation, not just from the moment of re-entry, but from any future interaction. The objects are still there, but for all practical purposes they are beyond reach. And yet, they are not isolated in the same way as the surface above them, because beneath the water, the environment is not empty. It is structured in ways that are not immediately visible from above. Currents move slowly across the seafloor, sediments accumulate, microscopic life continues to exist even at those depths. The remains of spacecraft do not simply rest unchanged, they become part of that system, interacting with it over time. Materials degrade, surfaces become colonized by organisms adapted to extreme conditions, and what was once clearly artificial begins to blend slowly into the natural environment. This does not erase their origin, but it does transform their presence. And this transformation adds another layer to the idea of isolation. On the surface, Point Nemo is defined by absence, by the lack of features, the lack of human activity, the lack of visible structure. Beneath the surface, there is a different kind of presence, one that is hidden, dispersed, and largely unobserved. The remains of objects that once represented some of the most advanced technology ever created, now existing in one of the least accessible parts of the planet. It is a convergence that is rarely considered, because it exists out of sight, beyond the usual scope of attention. But it is real, and it continues to grow incrementally with each controlled re-entry. This does not turn the region into something crowded or cluttered. The scale of the ocean is too vast for that. Even with multiple spacecraft falling into the same general area, the distribution remains sparse, the distances between individual objects still significant. But the pattern is there, subtle and cumulative, adding a dimension to the place that is not immediately apparent from above. And when you consider that, the idea of disappearance becomes less about removal and more about transition. Objects do not cease to exist. They move from one environment to another, from orbit to ocean, from visibility to obscurity. And in that transition, they become part of a place that is already defined by its distance from everything else. A place where even the remnants of human activity are absorbed into a system that remains, for the most part, beyond direct observation. And if you follow that descent all the way down, past the surface where the waves erase any trace of what entered from above, past the layers of water where light fades and pressure builds, you arrive in an environment that challenges one of the most persistent assumptions about the ocean, that it is always full of life. Because in this part of the Pacific, beneath the same region defined by distance and absence at the surface, there exists something that oceanographers describe in very different terms, not as a thriving ecosystem, but as a desert. The South Pacific Gyre, a massive system of circulating currents, dominates this region. At first, that might sound like a dynamic and active environment, a place where water is constantly moving, mixing, and transporting nutrients across vast distances. But the reality is more subtle. Gyres are not chaotic. They are stable, slow-moving systems that rotate over long timescales, creating a kind of containment zone in the center. Water enters these systems from the edges, but once inside it tends to remain there, circulating gradually rather than being exchanged rapidly with surrounding regions, and over time, that has consequences. Because nutrients in the ocean do not appear evenly, they are often introduced through upwelling, where deeper, nutrient-rich water rises to the surface, or through proximity to land, where rivers and coastal processes contribute organic material. In the center of a gyre, far from coastlines and with minimal vertical mixing, those sources are largely absent. The result is a region where the surface waters become increasingly depleted. Phytoplankton, the microscopic organisms that form the base of the ocean's food web, depend on those nutrients to grow. In more productive regions, they multiply in vast numbers, supporting complex ecosystems that extend upward to fish, marine mammals, and birds. But here, their growth is limited. The water appears clear, almost unnaturally so, not because it is pure in the sense of being untouched, but because it lacks the particles and organisms that would normally give it color and density. From above, this clarity can be striking. The ocean takes on a deep, uniform blue, uninterrupted by the variations that indicate biological activity. But that visual simplicity reflects a deeper reality. There is life here, but it exists at a much lower density than in most other parts of the ocean. The food web is compressed, simplified, operating at a scale that is difficult to detect without specialized instruments, and this has cascading effects. With fewer phytoplankton, there is less energy entering the system. With less energy, there are fewer organisms at higher levels of the food chain. The entire ecosystem becomes sparse, not in the sense of being empty, but in the sense of being limited, constrained by the availability of resources that are not replenished in significant amounts. Even the currents themselves contribute to this isolation. While the gyre is a system of movement, that movement is slow and circular, not the kind of dynamic flow that brings new material into the center. Instead, it tends to trap what is already there, creating a stable but nutrient-poor environment. This stability is one of the reasons why the region remains so consistent over time. It does not experience the same seasonal fluctuations or sudden changes that occur in more active parts of the ocean. But that consistency comes at the cost of productivity. It is a trade-off that defines the character of the region beneath Point Nemo. And this creates an important contrast with how we often imagine the deep ocean. There is a common perception that the further you go from land, the more mysterious and abundant life becomes, as if remoteness itself implies richness. In some cases, particularly around hydrothermal vents or other unique geological features, that can be true. But those are exceptions, localized environments where specific conditions allow life to flourish. In the vast open ocean, especially in regions like this, the opposite can be the case. Distance from land does not always mean more life. It can mean less, because the processes that support biological productivity are no longer present in the same way. This is not an absence of life, but a different kind of balance, one that operates at the lower limits of what the ocean can sustain. And it extends all the way down. As organic material from the surface sinks, it becomes the primary source of energy for deeper ecosystems. In more productive regions, this marine snow falls in relatively large amounts, supporting a diverse range of organisms on the seafloor. Here, that input is reduced. The particles that descend are fewer, more dispersed, arriving slowly over time. Life at depth adapts to these conditions, becoming more efficient, more specialized, capable of surviving on minimal resources. The organisms that exist there are often small, slow-growing, adapted to an environment where energy is scarce and competition is low. And this scarcity adds another dimension to the idea of isolation. On the surface, the region is defined by distance from land and human activity. Below, it is defined by distance from the processes that sustain more vibrant ecosystems elsewhere. It is isolated not just geographically, but biologically, existing at the edge of what is possible in terms of productivity. And yet, it remains part of the same global system, connected through currents, through atmospheric interactions, through the slow exchange of water over long timescales. It is not cut off completely, but it is separated enough that its characteristics diverge in noticeable ways. This makes Point Nemo more than just a point of maximum distance. It becomes a place where multiple forms of isolation overlap: physical, human, and ecological, each one reinforcing the others, each one contributing to an environment that is defined as much by what is missing as by what is present. And as you begin to understand that, the emptiness of the surface starts to feel less like a simple absence and more like the visible expression of processes that extend far below, shaping a region that remains in many ways one of the most understated extremes on the planet. If you could take a sample of water from this region and look at it under a microscope, what you would see would not match the emptiness suggested by the surface. It would not be full, not crowded, not active in the way coastal waters are, but it would not be empty either. Instead, it would reveal something quieter, more subtle, a form of life that exists at the very edge of what the environment can support. In most parts of the ocean, microbial life is abundant to the point of invisibility, not because it is rare, but because it is everywhere. Billions of microorganisms can exist in a single litre of seawater, forming the foundation of entire ecosystems. Here, those numbers drop significantly. The difference is not absolute absence, but reduction, a thinning out of life to levels that force every organism to operate with extreme efficiency. Bacteria, archaea, and microscopic algae still exist, but they do so under constraints that shape their behavior in fundamental ways. They grow more slowly. They consume energy more carefully. They exist in a kind of metabolic balance where nothing is wasted, because there is nothing extra to waste. And this changes the entire rhythm of life. In more productive waters, biological processes happen quickly. Organisms reproduce, compete, consume, and die in cycles that can be measured over hours or days. In this region, those cycles stretch out. Growth becomes incremental. Reproduction becomes less frequent. Survival depends not on speed or dominance, but on persistence. Some microorganisms enter states of dormancy, reducing their activity to the bare minimum required to remain viable, waiting for conditions that may never significantly improve. Others adapt by becoming more efficient at extracting nutrients from extremely dilute sources, developing biochemical pathways that allow them to survive where others cannot. This is life operating under limitation, not as a temporary condition but as a constant state. And as you move beyond the microscopic scale, the same pattern continues. Small marine organisms, zooplankton, tiny drifting animals that feed on phytoplankton are present, but in lower densities. Their populations fluctuate less dramatically, their numbers constrained by the limited availability of food. Larger organisms that depend on them, small fish, gelatinous creatures, and other mid-level species become less common as well. The entire food web compresses, not collapsing, but thinning, each level supporting fewer individuals than it would in more nutrient-rich regions. It becomes a system where energy moves slowly, where each transfer is limited, where abundance is replaced by scarcity. And yet, within that scarcity, there is a different kind of adaptation. Some species that inhabit these regions are not simply surviving despite the conditions, but because of them. With fewer competitors and fewer predators, certain organisms find niches that would not exist in more crowded environments. They evolve to exploit resources that are too minimal for others to rely on, becoming specialists in low-energy survival. Their bodies reflect this. They are often smaller, more streamlined, requiring less energy to maintain. Their behaviors are adapted to conserve resources, minimizing movement, reducing unnecessary activity. Even their life cycles adjust, with longer lifespans and slower development, strategies that align with an environment where rapid growth is not possible. And this extends all the way to the deepest parts of the water column. As organic material sinks from the surface, the amount that reaches the depths here is limited. The particles are fewer, more dispersed, often consumed before they can travel far. By the time they reach the seafloor, what remains is minimal, a thin, continuous input of energy that supports a sparse but persistent community of organisms. Deep-sea microbes, small invertebrates, and other specialized species exist in this environment, adapted to conditions where food arrives slowly and unpredictably. They do not rely on abundance, they rely on patience. And this creates an ecosystem that operates on entirely different timescales. Processes that would take days or weeks elsewhere can take months or years here. The accumulation of biomass is slower. The turnover of populations is reduced. Everything is extended, stretched out over time, as if the entire system is operating in slow motion. And yet, it remains stable. It does not collapse, because it is not dependent on high levels of input. It is built around the idea of limitation, structured in a way that allows it to persist under conditions that would challenge more complex ecosystems. This is what makes life at Point Nemo so compelling. It is not dramatic in the way that we often associate with extreme environments. There are no towering organisms, no visible burst of activity, no obvious signs of richness. Instead, there is a quiet resilience, a demonstration of how life can adapt to the most minimal conditions and continue, not by expanding, but by enduring. And in that sense, the isolation of this place is not just about distance or emptiness. It is about thresholds, about how close an environment can come to being uninhabitable while still supporting life. It exists near that boundary, where the difference between survival and absence becomes very thin. And as you consider that, the idea of isolation takes on another dimension. It is no longer just about how far this place is from everything else, but about how different it is in the way life functions within it. It is a region where the usual expectations do not apply, where abundance is replaced by restraint, where persistence becomes the defining characteristic, and it continues, quietly, beneath the surface, largely unnoticed, a reminder that even in the most remote and limited environments, life does not disappear. It adapts, it adjusts, and it finds a way to remain, even at the very edge of what is possible. What makes this place so persistently empty is not just how far it is from land, but how the entire planet is constantly moving around it in ways that quietly reinforce that isolation. The ocean is not still. It never has been. Beneath what looks like a flat, endless surface, there is a global system in motion, a network of currents, temperature gradients, and pressure differences that connect every ocean basin into a single, circulating body of water. These movements are driven by wind, by the rotation of the Earth, by differences in heat between the equator and the poles, and by the subtle pull of density changes as water becomes more or less salty. Together, they create patterns that are vast in scale, structures that can span entire hemispheres, shaping where nutrients travel, where life concentrates, and where it struggles to exist. In the South Pacific, where this isolated point lies, one of those structures dominates everything, a massive rotating system known as a gyre. It is not something you can see from the surface in any obvious way. There are no clear boundaries, no visible edges. But if you could trace the movement of water over time, you would see it forming a slow circular pattern, thousands of kilometers across, turning steadily under the influence of prevailing winds and the Coriolis effect caused by Earth's rotation. This rotation is not fast. It does not create dramatic whirlpools or visible spirals. Instead, it is subtle, almost imperceptible on a human timescale, but relentless over months and years, and as it turns, it does something critical. It traps water in its center. Nutrients in the ocean typically come from a few key sources. Near coastlines, they're delivered by rivers, carrying minerals and organic material from land into the sea. In colder regions, deep water rises to the surface through a process called upwelling, bringing nutrients that have accumulated in the depths back into the sunlight where they can fuel biological growth. But in the center of a gyre, both of these inputs are largely absent. There are no nearby land masses to supply fresh material, and the circular motion of the water creates a kind of stability that prevents deeper, nutrient-rich layers from rising. The surface becomes isolated not just geographically but chemically, cut off from the processes that usually sustain life. Over time, this leads to a gradual depletion. Organisms at the surface consume what nutrients are available, but without a steady supply to replace them, those levels drop. The system reaches a kind of equilibrium, but it is an equilibrium defined by scarcity. The water becomes clearer, not because it is cleaner in the sense we might think, but because there is less in it, fewer particles, fewer organisms, less biological activity overall. It is one of the reasons why satellite images of this region often show deep, uniform shades of blue. The colour itself becomes a signal of what is missing, and this is where the concept of isolation becomes more complex. It is not just about being far away. It is about being positioned within a system that actively maintains that distance in functional terms. Even if you could instantly move a large amount of nutrient-rich water into this region, the surrounding circulation would eventually disperse it, returning the system to its previous state. The gyre does not just create isolation once, it sustains it continuously, and this has implications that extend far beyond a single point on a map. It shows how large-scale planetary processes can shape local environments in ways that are not immediately obvious. From above, the ocean looks uniform, a continuous expanse without clear divisions. But beneath that appearance there are structures, invisible boundaries that determine how energy and matter move. Some regions become highly productive, supporting dense ecosystems, fisheries, and complex food webs. Others, like this one, become deserts, not because they are inherently incapable of supporting life, but because the systems around them limit what is available. And it also challenges the way we think about remoteness. Distance alone does not define how isolated a place is. There are regions closer to land that are more connected in terms of nutrient flow, where currents bring in resources from far away, linking them to distant ecosystems. Here, despite being part of a global ocean, the connection is weakened. The water is part of the same system, but it circulates in a way that minimizes exchange with more productive areas. It is connected in structure, but isolated in function. And as you consider that, the idea of Point Nemo becomes less about a single coordinate and more about a convergence of conditions. It exists where geographic distance, atmospheric patterns, and oceanic circulation align to create one of the most stable low-energy environments on the planet. It is not an accident. It is the result of systems interacting over scales that are difficult to fully grasp, producing a region where change happens slowly, where inputs are limited, and where the balance remains tilted toward minimalism. The ocean, in this sense, is not just a backdrop. It is an active participant, shaping the characteristics of this place in ways that are both precise and persistent. And once you begin to see it that way, the emptiness here starts to feel less like a void and more like a product, something created and maintained by the continuous motion of the planet itself, an outcome of forces that operate far beyond any single location, yet define it completely. Even in a place where almost nothing seems to happen, the ocean is never truly silent, and what cannot be seen begins to reveal itself in a different way, through sound that travels far beyond what any human sense would normally detect, moving through water with a clarity and reach that turns this seemingly empty region into part of a vast, hidden network of acoustic connections. In air, sound fades relatively quickly, absorbed, scattered, interrupted by obstacles and distance. But in the ocean, the physics changes completely. Water is denser, more uniform, and capable of carrying sound waves across enormous distances with very little loss of energy. A noise created in one part of the ocean can travel hundreds, sometimes thousands of kilometers, bending and refracting as it moves through layers of varying temperature and pressure, following paths that are shaped by the structure of the ocean itself. And within that structure, there exists something even more remarkable, a natural phenomenon known as the SOFAR channel, a horizontal layer in the ocean where sound becomes trapped and guided, allowing it to propagate across entire ocean basins. This channel forms because of how sound speed changes with depth. Near the surface, warmer temperatures increase the speed of sound, while at greater depths, increasing pressure does the same. Between these two influences, there is a point where sound speed reaches a minimum, creating a kind of acoustic corridor. When sound waves enter this layer, they are refracted back toward the center, unable to escape upward or downward, effectively contained within a long, invisible pathway that can carry them across extraordinary distances. It is a system that was first understood in the context of submarine navigation and oceanographic research, but its implications go far beyond human technology. In a region like the one surrounding Point Nemo, where visual cues are almost non-existent, this acoustic environment becomes one of the few ways the ocean communicates across space. A storm thousands of kilometers away can generate low-frequency sounds that travel through the SOFAR channel, reaching this isolated region long after the weather has passed. The cracking of ice in polar regions, the movement of tectonic plates beneath the seafloor, even the distant calls of large marine animals, all of these can move through the ocean in ways that connect places that would otherwise seem completely separate. And this creates a different kind of presence. On the surface, there is emptiness, a lack of visible activity, but beneath that surface, there is a continuous flow of information carried by sound. Hydrophones placed in remote parts of the ocean can detect signals that originate from across entire oceans, allowing scientists to map events that would otherwise go unnoticed. In some cases, these recordings reveal patterns that are both predictable and mysterious, rhythms of natural processes that repeat over time, alongside sudden, unexplained sounds that spark curiosity and investigation. One of the most well-known examples of this is a sound detected in the late 1990s by underwater listening stations, a powerful, low-frequency noise that travelled across a large portion of the Pacific. It was unlike typical biological or geological signals, leading to speculation about its origin. While it was later attributed to natural ice movements, the initial uncertainty highlights how much of this acoustic world remains only partially understood. In a place like Point Nemo, where direct observation is limited, sound becomes one of the primary ways to study and interpret what is happening. It reveals that isolation in the visual sense does not equate to complete separation. The region is still part of a dynamic system, receiving signals from distant sources, connected through a medium that operates under different rules than those we experience on land. And this has practical implications as well. Submarines rely on this acoustic environment for navigation and communication, using the properties of sound propagation to detect objects and transmit information over long distances. Marine research uses it to track animal movements, monitor seismic activity, and study the structure of the ocean itself. Even the absence of certain sounds can be informative, indicating regions of low biological activity or minimal human presence. And here, that absence becomes particularly noticeable. Compared to more active parts of the ocean, the acoustic environment around this isolated point can be quieter in specific frequency ranges, reflecting the reduced levels of life and human activity. There are fewer ships, fewer large marine populations, fewer sources of constant noise. What remains are the deeper, more fundamental sounds of the ocean, those generated by natural processes that operate on a planetary scale. And this adds another layer to the understanding of isolation. It is not just about what is missing, but about what remains, what continues to move through this space even when everything else seems absent. The ocean does not become silent here. It becomes selective, carrying only certain signals, filtering out others, creating an environment where sound takes on a different role. It becomes a thread that connects this remote region to the rest of the world, not through visible pathways, but through waves that travel unseen, linking distant events in ways that are easy to overlook if you are only thinking in terms of distance and emptiness. And as you consider that, the perception of this place shifts again. It is no longer just a void in the middle of the ocean, but part of a network that operates beneath the surface, a system where information moves even when matter does not, where the absence of visible life does not mean the absence of activity. It is a reminder that the ocean, even at its most isolated, remains interconnected in ways that are subtle but profound, and that sometimes the only way to understand a place like this is not by looking at it, but by listening to what passes through it, quietly, continuously, across distances that redefine what it means to be alone. What makes these long-distance signals so compelling is not just how far they travel, but how difficult they can be to interpret once they are detected. Because in an environment where sound moves freely across entire ocean basins, the origin of a signal becomes blurred, stretched out across space in ways that make pinpointing a source far more complex than it might seem. When a hydrophone records a sound in the open ocean, especially in a region as remote as this, it is not simply capturing something that happened nearby. It could be recording an event that occurred hundreds or even thousands of kilometers away, a sound that has been refracted, bent, and guided through layers of water before arriving at the sensor. By the time it is detected, it carries the signature of its journey as much as the signature of its source. Frequencies may be altered, intensity reduced, timing spread out. The ocean does not just transmit sound, it reshapes it. And this is where uncertainty begins to emerge, not as a failure of science, but as a natural consequence of the medium itself. There have been moments in oceanographic research where recordings have captured signals that do not immediately match known patterns. These are not everyday occurrences, but when they happen, they draw attention, not because they suggest something extraordinary, but because they highlight the limits of current understanding. Scientists approach these signals with caution, not jumping to conclusions, but carefully analysing their characteristics, comparing them to known sources, and considering how the ocean environment might have modified them. One of the most well-known examples involved a powerful low-frequency sound detected across a large portion of the Pacific, recorded by multiple listening stations. Its amplitude was significant, its range unusually large, and its pattern did not immediately align with common sources like earthquakes or marine life. For a time it remained unidentified, not because it was beyond explanation, but because the available data was insufficient to draw a clear conclusion. Over time, further analysis suggested that it was likely caused by the fracturing and movement of large ice masses in polar regions, a natural process that can generate strong acoustic signals capable of travelling vast distances. The initial uncertainty was not a mystery in the sense of something unknown forever, but a reminder that interpretation requires context, and context in the open ocean is not always readily available, and this is a recurring theme in this environment. Signals are often received before they are fully understood. The ocean provides the transmission, but not always the explanation. Researchers rely on networks of sensors, comparing data from multiple locations, analysing the timing and frequency of signals to triangulate possible origins. Even then, the conclusions are often probabilistic rather than absolute, framed in terms of likelihood rather than certainty. This is not a weakness of the science, but a reflection of the complexity involved in studying a system that operates on such a large scale. In regions closer to land, where more variables can be controlled and more direct observations can be made, interpretation becomes easier. Here, in the middle of the ocean, where direct access is limited and signals can originate from almost anywhere, the process becomes more intricate. And yet, this complexity is also what makes the study of these signals valuable. Each recording adds to a growing body of knowledge, helping to refine models of how sound behaves in the ocean, how different sources produce distinct acoustic signatures, and how those signatures change as they travel. Over time, patterns emerge. Certain types of events become more recognizable. The unknown becomes known, not through sudden breakthroughs, but through gradual accumulation of data and understanding. And still, there are moments when a signal does not fit neatly into existing categories, when something is recorded that requires further investigation. These moments are not treated as anomalies to be sensationalized, but as opportunities to learn, to question assumptions, and to improve the tools and methods used to study the ocean. In a place like this, where visual observation is limited and direct interaction is rare, Sound becomes one of the primary sources of information, but it is information that must be interpreted carefully with an awareness of its limitations. The absence of a clear source does not imply something extraordinary. It often simply reflects the challenges of working within a system where distance, depth, and dynamic conditions all play a role in shaping what is observed. And this reinforces a broader understanding of the ocean itself. It is not a static environment that can be easily mapped and categorized. It is a dynamic, interconnected system where events in one region can influence conditions in another, where signals can travel far beyond their origin, and where interpretation requires both precision and humility. The idea of isolation, when viewed through this lens, becomes more nuanced. Even here, in one of the most remote locations on the planet, the ocean carries traces of distant activity, echoes of processes occurring far away. The challenge is not detecting those traces, but understanding them, placing them within a framework that accounts for the complexity of the environment. And as research continues, as more data is collected and analysed, the picture becomes clearer, not in the sense that every signal can be immediately explained, but in the sense that the range of possibilities becomes better defined. The unknown shrinks, not because the ocean becomes simpler, but because our understanding of its behaviour improves, and in that process, the occasional unexplained signal serves a purpose, not as a mystery to be exaggerated, but as a reminder that there is still more to learn, that even in the most studied aspects of the ocean, there are layers of complexity that require careful, methodical exploration. When people think about the most remote places on Earth, their minds often go first to Antarctica, a vast continent of ice that feels detached from the rest of the world, cut off by distance, by extreme weather, and by an environment that seems almost entirely hostile to human life. And in many ways that perception makes sense, because Antarctica is difficult to reach, difficult to survive in, and for most of history it remained largely untouched. But when you begin to look at it more closely, and especially when you compare it to this point in the South Pacific, something becomes clear. Antarctica is remote, but it is not isolated in the same way. Antarctica has structure, it has boundaries, it has a physical presence that defines it, a continent rising above the ocean, visible, measurable, something you can approach, land on, traverse, and even inhabit, at least temporarily. There are research stations scattered across its surface, occupied year-round by scientists and support crews, who study everything from climate patterns to cosmic radiation. Aircraft regularly land on prepared runways, ships navigate through seasonal sea ice to deliver supplies, and communication systems connect these outposts to the rest of the world. It is harsh, but it is not disconnected. There are systems in place that link it to global networks, logistical, scientific, and technological. And beyond human presence, Antarctica supports ecosystems that, while limited compared to more temperate regions, are still active and complex. Along its coasts, marine life thrives in nutrient-rich waters, where upwelling currents bring food to the surface, supporting populations of krill, fish, seals, and whales. Even on land, life exists in specialized forms, microorganisms, mosses, and lichens that have adapted to survive in extreme cold and dryness. There are seasonal changes, cycles of light and darkness, variations in temperature and activity that create a dynamic environment. It is a place that can be studied directly, observed, measured, experienced. Now compare that to a remote island in the middle of the ocean, perhaps thousands of kilometers from the nearest continent. At first glance it might seem equally isolated, a small piece of land surrounded by vast distances of water, but even here there are defining features. An island has edges. It creates a boundary between land and sea, a place where ecosystems concentrate, where birds nest, where plants grow, where marine life gathers along its shores. It becomes a point of interaction, a location that can be reached, even if infrequently by ships or aircraft. Some of the most remote islands on Earth still have human inhabitants, or have been visited and documented, mapped and integrated into global systems of navigation and communication. They exist as destinations, places with identity and presence. What makes Point Nemo fundamentally different is that it has none of these characteristics. There is no land, no boundary, no feature that distinguishes it from the surrounding ocean except its position relative to everything else. You cannot see it, you cannot stand on it, you cannot approach it in the traditional sense because there is nothing to approach. It is defined entirely by distance, by the fact that in every direction, the nearest land is equally far away. And that creates a type of isolation that is not just about remoteness, but about the absence of structure. In Antarctica, even in its most extreme regions, you can orient yourself. There are landmarks, even if they are subtle, mountains beneath the ice, variations in terrain, the presence of the continent itself as a reference point. On an island, no matter how small, there is always a centre, a place where land exists, where you can anchor your sense of location. At Point Nemo, there's none of that. The environment offers no reference, no variation that can be used to define position in any intuitive way. The horizon looks the same in every direction. The surface of the water provides no indication of where you are within the vast expanse. It is a place that exists only in coordinates, in numbers on a map, rather than in physical features that can be directly experienced. And this difference has practical implications. Reaching Antarctica, while challenging, is a matter of planning and resources. There are established routes, known landing sites, infrastructure that supports access. Reaching a remote island may require long voyages, but it is still a journey towards something tangible. Reaching Point Nemo is different. It is not a destination in the traditional sense. There is no reason to go there beyond the fact that it exists. No resources to extract. No ecosystems to study that cannot be observed elsewhere. No strategic advantage to being there. And because of that, it remains largely untouched. Not because it is impossible to reach, but because there is no purpose in doing so. This is where the distinction between remote and isolated becomes most clear. Remoteness is about distance, about how far something is from other places. Isolation, in this context, is about disconnection, about the lack of interaction, the absence of systems that link a place to the rest of the world. Antarctica is remote, but it is connected through science, through logistics, through the ecosystems that link it to global ocean currents and atmospheric patterns. Even the most distant islands are part of networks, biological, geographical, or human. Point Nemo, by contrast, exists outside of these connections in a more complete sense. It is part of the ocean, part of the global system, but it does not function as a node within that system. It does not receive, it does not transmit in the ways that other locations do. It is simply there, defined by its position and maintained by the conditions that surround it. And understanding that difference changes how you think about isolation. It is not just about finding the place that is hardest to reach, or the place that feels the most distant. It is about identifying where the usual patterns of connection break down, where the systems that link the planet together become weakest. In that sense, the most isolated place on Earth is not a continent of ice or a remote island in the ocean. It is a point, an absence of features, a location where distance, lack of structure, and minimal interaction all converge to create a level of separation that is fundamentally different from anything else on the planet. And yet, even here, in a place defined by absence, by distance, by the near-complete removal of human presence and natural abundance, there is something that has managed to arrive without ships, without infrastructure, without intention, carried not by direct movement, but by the same global systems that shape the ocean itself. It does not arrive all at once, and it does not announce itself. It accumulates slowly, almost invisibly, becoming part of the environment in a way that is difficult to detect without careful measurement. If you were to take that same sample of water again, the one that already revealed sparse life, and examine it with the right tools, you would find traces of something else, fragments so small they are often measured in micrometers, particles that do not belong to this ecosystem, but have become embedded within it. Microplastics. They are not unique to this region. In fact, they have been found in every part of the ocean that has been studied, from coastal waters to the deepest trenches. But their presence here carries a different weight, because this is a place that, by all intuitive measures, should be beyond the reach of direct human influence. There are no cities nearby, no rivers delivering waste, no visible pathways that connect it to sources of pollution, and yet the particles are there, suspended in the water, integrated into the same currents that move nutrients and energy around the planet. To understand how they arrive, you have to think in terms of scale and time. Plastic does not disappear in the ocean. It breaks down slowly under the influence of sunlight, mechanical stress, and chemical processes, fragmenting into smaller and smaller pieces. These fragments can remain in the water for decades, even centuries, moving with currents, spreading across entire ocean basins. The gyres that create regions of low nutrient availability can also act as accumulation zones for floating debris, not because they attract it in a deliberate sense, but because their circular motion reduces the likelihood of material escaping once it enters. Over time, even areas that are far from direct sources of pollution begin to show measurable concentrations of these particles, and it is not just plastic. Chemical compounds, many of them produced through industrial processes, also find their way into the ocean, carried by atmospheric transport, deposited by rainfall, or introduced through distant water masses that eventually circulate into even the most isolated regions. Some of these substances are persistent, meaning they do not easily break down, allowing them to remain in the environment long enough to be distributed globally. They can bind to particles, be taken up by organisms, and move through food webs, even in ecosystems where overall biological activity is low. In a place like this, where life operates under strict limitations, even small changes in the chemical composition of the water can have implications that are not immediately visible but are still significant over time. What makes this particularly striking is the contrast between expectation and reality. This is a location defined by its separation from human systems, by the absence of direct interaction, and yet it is not untouched. The same processes that isolate it geographically also connect it chemically. The ocean does not recognize boundaries in the way that land-based systems do. It does not contain the effects of human activity to specific regions. Instead, it redistributes them, gradually, continuously, until even the most remote locations reflect the influence of distant sources. And this influence is not always obvious. There are no visible signs on the surface, no accumulation of debris that clearly marks the presence of pollution in the way it might along a coastline. Instead, it exists at a scale that requires instrumentation to detect, integrated into the water itself, part of the background conditions that define the environment. It becomes another layer of complexity, another factor that shapes how life persists in this already constrained system. And this leads to a broader realization about what isolation means in a connected world. It is possible to be physically distant, to be removed from direct human presence, and still be influenced by human activity through indirect pathways. The idea of a place being completely untouched becomes increasingly difficult to sustain when you consider how effectively the ocean and atmosphere distribute materials across the planet. Even here, where ships rarely pass and no infrastructure exists, the cumulative effects of global processes are still present, subtle but measurable. And this does not diminish the uniqueness of this location. It remains one of the most isolated places on Earth in terms of direct interaction and accessibility. But it does change the narrative. It shifts the focus from isolation as a form of purity to isolation as a condition within a larger interconnected system. A system where actions in one part of the world can have consequences in another, not immediately, not dramatically, but gradually over time, through pathways that are not always visible but are always active. And as you consider that, the image of this place evolves once again. It is no longer just a distant point in the ocean, defined by what is not there. It becomes a reflection of the planet as a whole, a location where the combined effects of natural systems and human activity converge in subtle ways. It remains quiet, it remains sparse, but it is not separate. It is part of a network that extends across the entire Earth, a reminder that even the most isolated environments are still connected to everything else, not through direct presence, but through the continuous movement of water, air, and the materials they carry. When you begin to follow the path of anything that enters the ocean, whether it is a fragment of plastic, a dissolved chemical, a particle of organic matter, or even heat itself, a pattern starts to emerge that is difficult to ignore, because no matter where it begins, it rarely stays there. The ocean is not a collection of isolated regions that hold on to what they receive. It is a continuous system of movement, driven by forces that operate over scales of time and distance that are far beyond everyday human experience. Currents flow across entire basins, surface waters sink and re-emerge thousands of kilometers away, and what seems local at one moment becomes global over time. The idea that something can be discarded, that it can be removed from one place and effectively disappear into another, begins to break down when you consider how these systems actually function. There is no true separation, no final destination where things simply stop moving. Instead, there are pathways, loops, and cycles that redistribute everything slowly but persistently across the entire planet. This becomes especially clear when you look at the deeper circulation of the ocean, sometimes referred to as the global conveyor, a system where water masses formed in one region travel through the depths for decades or even centuries before returning to the surface elsewhere. Cold, dense water sinks near the poles, carrying with it dissolved gases and particles, then begins a slow journey through the deep ocean, moving along pathways shaped by the seafloor and the structure of the planet itself. Eventually, through processes like upwelling, that same water returns to the surface, often far from where it began, bringing with it whatever it has carried along the way. It is a system that connects distant regions in ways that are not immediately visible, linking the polar oceans to the tropics, the surface to the depths, and the past to the present. And this movement is not limited to water alone. Anything that can be carried within it becomes part of the same journey. A particle released into the ocean today does not remain fixed in place. It becomes subject to currents, to mixing, to the gradual processes that spread it outward. The timescales may vary. Some materials move quickly, transported by surface currents over the course of months or years. Others move more slowly, becoming part of deeper circulation patterns that take decades to complete a full cycle. But the direction is consistent, outward, across boundaries, through systems that do not recognize the divisions we impose on maps. And this has profound implications for how we understand isolation. A place like Point Nemo appears, at first glance, to be disconnected, separated from everything else by vast distances. But when viewed through the lens of these global systems, it becomes clear that it is not isolated in a functional sense. It is part of the same network, influenced by the same movements, subject to the same long-term redistribution of matter and energy. What reaches this point may take time, may arrive in diluted or altered forms, but the pathways exist. The connection is real, even if it is not immediately visible. This is why the idea of a way becomes difficult to define. On land, it is possible to move something out of sight, to transport it to a location where it no longer affects the immediate environment. But on a planetary scale, especially within the ocean, there is no true endpoint. There are only stages in a continuous process of movement and transformation. Materials may become less concentrated, less noticeable, but they do not vanish. They are redistributed, integrated into new contexts, carried into regions that may seem unrelated to their origin. And over time, this creates a kind of global memory, a record of inputs that is spread across the entire system. In the case of the ocean, this memory is not stored in a single place. It is distributed, embedded in water masses, sediments, and biological systems. It is dynamic, constantly changing as new inputs are added and existing ones are moved and transformed. And because of this, even the most remote locations become part of the record. They receive traces of processes that began far away, long before those materials arrived, and this perspective changes how you think about scale and consequence. Actions that seem localized can have effects that extend far beyond their point of origin. Not immediately, not in ways that are always easy to trace, but gradually through the same systems that connect all parts of the ocean. The distance between cause and effect becomes stretched out, both in space and in time, making it harder to perceive the relationship, but not eliminating it. And this is where the significance of a place like this becomes more than just geographical. It becomes a reference point for understanding how the planet operates as a whole. It shows that even in a location defined by its remoteness, the influence of global systems is still present. It demonstrates that isolation, in the absolute sense, does not exist on a connected planet. There are degrees of separation, differences in how strongly a place is linked to others, but the underlying connectivity remains. And as you follow that idea further, the concept of the loneliest place on Earth begins to shift again. It is still the most distant point from land, still the place where direct human presence is least likely, but it is not separate from the processes that shape the rest of the world. It is part of them, influenced by them, even if the effects are subtle and slow to appear. The ocean does not allow for complete disconnection. It distributes, it circulates, it ensures that over time, everything becomes part of a larger system. And in that sense, the true story of this place is not just about how far it is from everything else, but about how, despite that distance, it remains linked to the entire planet through pathways that operate continuously, quietly, and without regard for the boundaries we imagine. If you were to step back even further, beyond the ocean, beyond the atmosphere, and look at the Earth as a whole, this point in the South Pacific would not stand out in any visible way. There is no mark, no feature, no indication that it is different from the rest of the ocean surface. And yet mathematically, geometrically, it represents something very precise, the result of how land is arranged across the planet, of how continents have formed, drifted and settled over millions of years, creating an uneven distribution that leaves certain regions more distant from solid ground than any others. This is not a place that was created with intent. It was not shaped for a purpose. It is the outcome of processes that operate on timescales so large that they are difficult to fully comprehend. The slow movement of tectonic plates, the formation and breakup of supercontinents, the shifting of coastlines, all combining to produce the current layout of Earth's surface. The continents we recognize today are not fixed. They are fragments of a larger system, pieces of crust that have moved, collided and separated over geological time. Hundreds of millions of years ago they were arranged differently, clustered together in configurations that would have eliminated any such point of extreme oceanic isolation. As they drifted apart, driven by forces deep within the planet, oceans expanded, basins deepened, and new distances were created. The Pacific Ocean itself, the largest and deepest of Earth's ocean basins, became a dominant feature, occupying a vast portion of the planet's surface. And within that expanse, the relative positions of surrounding landmasses, South America to the east, Australia to the west, Antarctica to the south, created a region where the distances between them are maximized. Point Nemo exists because of that arrangement. It is the location that, when calculated, sits furthest from any coastline, a point that emerges not from observation but from geometry. If you take the map of the Earth and apply a simple principle, finding the location that maximizes the minimum distance to land, you arrive at this point. It is a solution to a problem, a result that can be derived through computation, independent of whether anyone ever physically visits it. This is what makes it fundamentally different from most places we think about. It is not defined by what is there, but by what is not. Its identity comes entirely from its relationship to other locations, from the absence of nearby land rather than the presence of any distinguishing feature. And that raises an interesting perspective on how we understand geography. We often think of places in terms of their characteristics: mountains, rivers, cities, ecosystems, things that can be described directly. But there are also places that are defined relationally by how they are positioned within a larger system. Point Nemo is one of the clearest examples of this. It is not a destination in the traditional sense. It is a coordinate that represents a maximum, a point where a specific condition is met more strongly than anywhere else on the planet, and that condition is distance. But even that distance is not static. It is tied to the current configuration of the continents, which continues to change, albeit slowly. Over millions of years, as tectonic plates continue their movement, the position of this point will shift. The distances will be recalculated, and a new location may eventually take its place as the most isolated point in the ocean. In that sense, even this extreme of isolation is temporary, a snapshot of a dynamic system caught at a particular moment in geological time. This reinforces the idea that the Earth is not a fixed entity, but a constantly evolving one, where even the most seemingly permanent features are subject to change. and it also highlights how much of what we define as unique or extreme is dependent on context. Point Nemo is the most isolated place on Earth today, but only because of how the continents are arranged right now. In a different configuration, in a different era, that distinction would belong elsewhere. This does not diminish its significance. If anything, it adds another layer to it. It shows that even the most extreme conditions we can identify are part of a larger, shifting system, outcomes of processes that operate beyond human timescales and intentions. And as you consider that, the story of this place becomes less about a single point in the ocean and more about the planet as a whole, about how its structure, its history, and its ongoing movement combine to create locations that challenge our understanding of distance, isolation, and connection. It becomes a reminder that what we observe on the surface is the result of deeper processes, that the map we see is a temporary expression of forces that continue to shape the Earth in ways that are both gradual and profound. And in that context, Point Nemo is not an anomaly. It is a consequence, a natural outcome of how the planet is built and how it changes over time, a place that exists not because it was meant to, but because the conditions that define it happen to align here, at this moment, in this configuration of land and ocean. And when you finally strip everything else away, the distances, the systems, the science, the movement of continents and currents, what remains is something far more difficult to describe, because it is not something you can measure with coordinates or maps. It is the experience of being in a place that does not respond to you in any meaningful way. Every environment on Earth, even the harshest ones, usually provides some form of feedback. In a forest, there is movement, sound, variation. In a desert, there is heat, texture, wind shaping the landscape. In polar regions, there is ice cracking, shifting, reacting to temperature and pressure. Even in remote mountains, the terrain itself pushes back, demanding attention, forcing decisions. These environments may be extreme, but they are interactive. They acknowledge your presence, even if only through resistance. But here, that interaction breaks down almost completely. At this point in the ocean, the surface stretches out in every direction with a kind of uniformity that removes any sense of engagement. The water does not change in a way that signals progress or proximity. There are no landmarks to approach, no variations in terrain to interpret, no signs that you are moving toward or away from anything. The horizon remains fixed, a perfect circle that offers no information, no direction, no hint of what lies beyond it. The ocean here is not actively hostile. It is not violent or aggressive in the way storms can be. It is something far more disorienting than that. It is indifferent. It does not react to your presence because, in any meaningful sense, your presence does not matter to it. This indifference creates a very different kind of psychological environment. Humans are deeply tuned to feedback. We rely on constant signals from our surroundings to orient ourselves, to understand where we are, to anticipate what might happen next. When those signals are removed or reduced to near zero, the mind begins to struggle. Not because there is danger in the traditional sense, but because there is nothing to anchor perception. Imagine standing on the deck of a vessel in this region, looking out over the water. Minutes pass, then hours, and nothing changes. The light shifts slightly as the sun moves, but the scene itself remains almost identical. The waves rise and fall, but without variation, without pattern that suggests movement towards something. There is no approaching coastline, no passing ships, no distant objects to focus on. Even the sky, vast as it is, offers little variation beyond clouds that come and go without altering the overall emptiness. Over time, this lack of change begins to affect how you experience time itself. Without events to mark its passage, time can feel stretched, flattened, almost suspended. This is not the stillness of a calm place that invites reflection. It is a kind of sensory plateau, where the usual cues that define experience are absent, and this is where the true nature of isolation reveals itself. It is not just about being far from other people, it is about being in an environment that does not acknowledge you, that provides no confirmation of your existence beyond what you bring with you. In most places, even if you are alone, the environment participates in your experience. It reacts, it changes, it offers resistance or variation. Here, that participation is minimal. The ocean does not respond to your movement in any noticeable way. It does not alter its behavior because you are there. It does not provide signals that help you orient yourself within it. This creates a kind of one-sided interaction, where all the awareness comes from you, and none of it is returned. And that can be more unsettling than outright danger, because danger at least gives you something to engage with, something to respond to. Indifference leaves you with nothing but your own perception, unchallenged and unconfirmed. It is a reminder that much of what we consider reality is shaped by feedback loops between ourselves and our surroundings. When those loops are broken, even partially, the experience of being somewhere changes in a fundamental way. This is what makes this place unique, not just in terms of geography, but in terms of how it is experienced. It is one of the few locations on Earth where the environment approaches a kind of neutrality, where it neither supports nor opposes you in any obvious way. It simply exists, unchanged by your presence. And that neutrality can feel almost abstract, as if you are no longer interacting with a place, but with an idea of a place, a vast, uniform expanse that does not differentiate between before and after, between here and there. It is not that nothing is happening. The ocean is still moving, currents are still flowing, microscopic life is still persisting. But those processes operate on scales and levels that are not immediately perceptible. They do not register in a way that provides feedback to a human observer. And so, from a human perspective, it feels as though nothing is happening at all. This disconnect between what is actually occurring and what can be perceived adds another layer to the experience. It highlights the limits of our senses, the extent to which our understanding of a place depends on what we can detect directly. In a way, this location exposes that limitation more clearly than almost anywhere else. It shows what happens when the environment offers so little in terms of perceivable variation that our usual methods of interpretation begin to fail. And in that sense, it is not just isolated in space, but in experience. It stands apart not only because of where it is, but because of how it feels to be there, or perhaps more accurately, how little it feels like anything at all. And in the end, what this place quietly exposes is not just a remote coordinate in the ocean, but the outer edge of what human presence actually means on this planet. For centuries, exploration has been defined by the idea that there are always new places to reach, new territories to map, new frontiers waiting just beyond the horizon. From the first ocean crossings to the age of satellites, there has always been a sense that the unknown is something temporary, something that eventually becomes familiar through effort, technology, and time. But here that idea begins to shift, because this is not a place that resisted exploration in the traditional sense. It was not hidden behind mountains or buried under ice, or guarded by extreme conditions that prevented access. It simply existed in a position that made it irrelevant to human movement. outside the natural pathways we follow, outside the routes we create, outside the patterns that define how we navigate the world, and because of that it remained untouched not through difficulty, but through absence of purpose. Even now, with global positioning systems capable of pinpointing any location on Earth within meters, with satellites constantly scanning the surface of the planet, this point remains more of an abstraction than a destination. We can locate it precisely, describe it mathematically, model it in simulations, and observe it indirectly through data, but very few people have ever experienced it directly. Not because they cannot, but because there is almost no reason to. And that distinction matters. It marks a boundary between what we can know and what we choose to engage with. Because modern exploration is no longer limited by the inability to reach a place, but by whether reaching it has meaning. In the past, remote locations were often tied to discovery, to resources, to strategic value, to the expansion of knowledge in ways that justified the effort required to get there. But this place offers none of those incentives. It does not reveal new landforms. It does not contain unique ecosystems that cannot be studied elsewhere. It does not serve as a critical link in global systems that require direct human presence. It exists, fully defined and yet largely unvisited, a reminder that not every part of the world needs to be experienced to be understood, and not every coordinate invites exploration simply because it exists. And yet, that very lack of interaction creates a different kind of significance, because it forces a reconsideration of what it means to reach something. Is a place truly known if it has been mapped, measured, and analysed, but never directly experienced by more than a handful of people? Or does knowledge without presence remain incomplete in some way? This is where the distinction between data and experience becomes most apparent. From a scientific perspective, this location is not unknown. Its position is fixed. Its surrounding environment is studied. Its role within larger oceanic systems is understood. But from a human perspective, it remains almost entirely outside lived experience. There are no stories tied to it in the way there are for other remote places. No accounts of survival, no records of habitation, no historical narratives of discovery in the traditional sense. It entered human awareness not through exploration, but through calculation. It was identified because someone asked a question about distance, about where the farthest point from land might be, and then used the tools of mathematics and computing to find the answer. In that sense, it represents a different kind of frontier, one that is defined not by physical barriers, but by conceptual ones. It is a place that exists more clearly in theory than in memory, more precisely in coordinates than in stories. And that makes it fundamentally different from the places that have traditionally defined the limits of human reach, because those limits have usually been shaped by what we cannot do, by the environments we struggle to survive in, by the conditions that push against our capabilities. Here, the limit is not imposed by the environment in an obvious way. The ocean is vast, but not uniquely dangerous at this point compared to many other regions. The climate is not extreme in the way polar or equatorial zones can be. The barrier is not physical but contextual. It is the absence of reasons that keeps people away, the lack of connection to human systems that makes it functionally invisible despite being precisely known. And that reveals something important about the nature of exploration in the modern world, that the edges we encounter are no longer always defined by what is out there, but by how we relate to it. We have reached a point where much of the planet can be accessed if needed, where technology allows us to overcome many of the traditional obstacles that once defined the unknown. But that does not mean every place becomes part of our experience. Some remain distant not because they are unreachable, but because they exist outside the framework of what we consider necessary, useful, or meaningful to visit. And in that way, this location becomes less about geography and more about perspective. It is a point that exists at the intersection of complete knowledge and near total absence of human presence, a place that is fully mapped, fully defined, and yet almost entirely unexperienced. And that combination is rare. It suggests that even on a planet as extensively explored as Earth, there are still forms of distance that are not measured in kilometers alone. There are distances defined by relevance, by purpose, by the choices we make about where to go and why. This is one of those distances, not the farthest place we could reach, but one of the farthest places we have chosen not to. And in that choice, it reveals the true limits of human reach, not as a boundary imposed by the world, but as one shaped by us. And when everything is placed back into context, the distances, the systems, the absence of roots, the lack of life, the silence and the indifference, what remains is a single, precise idea anchored to a name that did not exist until we decided to define it. Point Nemo, not discovered in the traditional sense, not reached through exploration, not claimed or inhabited or even meaningfully visited, but calculated into existence as the answer to a question about distance. And yet, despite that abstract origin, it has become one of the clearest examples of what true isolation actually looks like on this planet. Because isolation here is not just about being far away, it is the combination of multiple absences layered on top of each other. The absence of land, of course, stretching thousands of kilometers in every direction, but also the absence of movement, with shipping routes bending around it, air traffic avoiding it entirely, and no reason for vessels to cross through its center. It is the absence of biological intensity, sitting within a gyre that limits nutrients and suppresses the kind of life that makes other parts of the ocean feel active and dynamic. It is the absence of structure, with no landmarks, no variations, no features that allow the human mind to orient itself or create a sense of place. And perhaps most importantly, it is the absence of interaction, an environment that does not respond, does not acknowledge, does not provide feedback in the ways we're used to. All of these layers combine into something that is more than the sum of its parts, because there are places on Earth that are remote, places that are dangerous, places that are difficult to reach, and places that are rarely visited. But very few locations combine all of those qualities with such complete neutrality. This is not a place that challenges you with extremes. It does not confront you with immediate danger or dramatic conditions. Instead, it removes almost everything that would normally define an experience, leaving behind a kind of baseline state where the environment exists independently of you in the most absolute sense. And that is what makes it so difficult to fully grasp, because most of our understanding of places comes from contrast, from differences, from the way environments change and respond and create variation. Here, those differences are minimized to the point where the concept of place itself becomes harder to hold on to. It becomes less about where you are and more about what is not there. And in that absence, the idea of isolation becomes clearer than it is anywhere else. Not as a feeling, not as a temporary condition, but as a measurable, definable reality. A point on the surface of the Earth where every direction leads to distance, where every path outward takes you away from the nearest sign of land, where the closest humans are often not on the surface at all, but moving above it, orbiting in a different layer of space, and even that detail, as striking as it is, fits into the larger pattern. Because this place does not stand out through a single extraordinary fact. It stands out because every aspect of it reinforces the same idea, that it exists outside the networks that connect the rest of the world, outside the systems of movement, of habitation, of interaction. It is not part of the pathways we use, and so it remains functionally invisible, even though we know exactly where it is. And that creates a kind of clarity. Because in a world where almost every location has been mapped, named, and integrated into some form of human activity, this point represents something different. Not unknown, not hidden, but unused. A place that exists without being part of the systems that define how we move through the planet. And that distinction matters. It shows that even with complete information, even with the ability to reach almost anywhere, there are still parts of the world that remain outside our experience simply because they do not intersect with our needs or our patterns, and that is what ultimately defines it. Not just as the most isolated place on Earth in terms of distance, but as a location where the absence of connection is complete. No routes lead through it, no systems depend on it, no structures anchor it, no interactions define it. It exists entirely on its own terms, shaped by forces that operate on a global scale, but expressed locally as stillness, emptiness, and neutrality. And in that sense, it is less like a destination and more like a reference point, a way of understanding what isolation looks like when it is taken to its logical extreme. Not dramatic, not exaggerated, not amplified, but stripped down to its simplest form. A single point, surrounded by nothing but distance, defined not by what is there, but by everything that is not.